So our next section is called direct variation. So with direct variation, we have this equation y equals kx. So y and x come from your points, and then k is called your constant. And so that's what the graph changes directly as each time. And if you notice, there's no plus or minus any extra things. It's just y equals something x, and again, that something is your constant. Now here we have, does the equation represent direct variation? So we first have to see if it's in y equals kx form. So in order to do that, you have to get y completely by itself. So to solve for y, we're going to divide each side by 7. So you get y equals 2 over 7x. So since there's nothing added over here, added or subtracted, it is direct variation. So direct variation of yes. And then the constant, which is k, is whatever is in front of the x value. So it's going to be 2 over 7. This one here, same question, is it a direct variation? If so, find the constant. So again, in order to check for direct variation, you have to solve for y. So we're going to subtract 4x over, so we get 3y equals negative 4x plus 8. Y is still not completely by itself, so we have to divide everything by 3. So we get y equals negative 4 over 3x plus 8 over 3. Because of this plus 8 over 3, it's not a direct variation. So it's not a direct variation, and if it's not a direct variation, then there's not a constant. Our next question says, suppose y varies directly with x and y equals 35 and x equals 5. What direct variation equation relates to x and y? So in order to have a direct variation equation, you have to have k filled in. But they don't tell us what k is, but they do tell us what x and y is. So we have to plug in x and y. So we're just looking at this first part here. So y equals 35. We don't know what k is, and then x equals 5. So instead of multiplying by 5, we're going to divide by 5. So then we get k equals 7. And then to write our direct variation equation, we're going to plug k in. So we're going to have y equals 7x. So this is our direct variation equation. Then from there, they ask us another question. They ask us to use that equation and find the value of y when x equals 9. So we're just going to plug in 9 for x. So we get y equals 7 times 9. So then y is going to equal 63. Now I want you to pause the video and go ahead and try this problem here. Same concept as the one that I just did. Now we're going to do this from a table, so we're going to see if y varies directly with x. If it does, we're going to write an equation for the direct variation. So this one's a little bit tricky because if we go up here on the left, it goes up by 4, and then it goes up by 2. On the right-hand side, it goes up by 6, and then it goes up by 3. But if we look at our changes, we're going to match up. So we're going to match up our 6 over 4. 6 over 4 simplifies down to 3 over 2 if you divide the top and the bottom by 2. And then if we look here at this change, this is actually going by 3 over 2. So the graph is changing by 3 over 2, just the table is only pointing out some of the points instead of going from each point. So our equation then is going to be y equals, and now with 3 over 2, since it's consistent, it's going to be our k, so it's going to be y equals 3 over 2x, and that would be your direct variation equation. So again, you're going to pause the video, you're going to try number 2 on your own.